Have you ever gazed at the night sky and wondered if we are alone in the universe? It's a question that has puzzled humanity for centuries, sparking the imaginations of scientists, philosophers, and dreamers alike. As we delve into the depths of the cosmos and the frontiers of science, we inch closer to potentially answering this profound question. One theory that could hold the key to our cosmic conundrums is the multiverse theory. This concept, born in the realm of cosmology and theoretical physics, dares to suggest a reality where our universe is merely one among countless others, each with its own unique set of physical laws and constants. Imagine a frothy sea of universes, each bubble representing a different reality. Could life exist in these other universes? Could we, in fact, not be alone? The multiverse theory suggests that our universe may not be the only one. Intriguing, isn't it? So, what is this multiverse theory all about? Well, let's unpack that a bit. The multiverse theory proposes an idea that might seem straight out of a science fiction novel. It suggests that our universe, the expansive cosmos we gaze upon when we look up at the night sky, is not the only one out there. In fact, it's just one universe among possibly countless others. Each of these universes exists independently, yet collectively, they form a vast, intricate multiverse. Picture this, if you will. Imagine that our universe is a bubble floating in an endless, frothy sea. Now imagine that this sea is teeming with other bubbles, each representing a different universe altogether. In some ways, it's a humbling thought, isn't it? The idea that our universe, with its billions of galaxies and trillions of stars, is merely one bubble in a sea of infinite universes. But here's where things get even more intriguing. The multiverse theory also suggests that each universe within the multiverse could have its own unique set of physical laws and constants. This means that the fundamental rules of physics as we understand them may not apply or may work differently in other universes. For instance, the force of gravity that keeps us grounded on Earth, or the speed of light that sets the cosmic speed limit, these might not hold the same values or even exist in other universes. The possibilities are truly mind-boggling. Other universes could harbor dimensions beyond our familiar three of space and one of time, or they could be governed by entirely different laws of physics that we can't even begin to comprehend with our current understanding. In a multiverse, the laws of physics could potentially vary greatly, allowing for a wide range of physical possibilities. This concept not only challenges our conventional understanding of reality, but also opens up a vast playground for our imagination and scientific curiosity. So as we delve deeper into the enigma that is the multiverse theory, let's brace ourselves for a journey that's sure to be full of surprises and wonder. This brings us back to our initial question: are we alone in the universe? The multiverse theory, with its vast number of universes, significantly increases the odds of extraterrestrial life. Imagine the multitude of universes as a cosmic roll of the dice. With each toss, the chance of rolling a universe where life can thrive becomes more likely. Now let's consider the conditions necessary for life as we understand it. These include a stable star, a planet with a suitable climate, and the presence of water and organic molecules. In our universe, these conditions are met on Earth. But what about the other universes in the multiverse? Well, if we take into account the sheer number of universes proposed by the multiverse theory, the likelihood of these conditions being met somewhere else becomes not just possible, but highly probable. Each universe could be like a cosmic laboratory, testing out different physical laws and constants. In some, the conditions might be too harsh for life to develop. In others, the laws of physics might not even allow for the formation of stars and planets. However, in a select few, the conditions might be just right for life to flourish. This doesn't necessarily mean that extraterrestrial life would resemble life as we know it. In a universe with different physical laws, life might evolve in ways that we can't even begin to imagine. We must broaden our definition of life beyond what we see on Earth. Life in these other universes could be based on different biochemistries, exist in different physical states, or even perceive reality in ways that are fundamentally different from our own. This leaves us with a tantalizing prospect. The multiverse theory, if true, could mean that we are not alone in the cosmos. Somewhere out there, in the vast sea of universes, there could be other forms of life looking up at their own sky and wondering the same thing. The sheer number of universes could mean that we are not alone. But what about our own universe? It seems perfectly fine-tuned for life. Indeed, it's a marvel to consider that our universe possesses the exact conditions required to support life. From the strength of gravity to the speed of light, the values of various physical constants appear to be balanced on a razor's edge, enabling the existence of galaxies, stars, planets, and ultimately, life itself. This phenomenon is often referred to as the fine-tuning of the universe, and it's been a subject of intense debate among scientists and philosophers alike. Some see it as evidence of a divine designer, while others argue it's simply a cosmic coincidence. But the multiverse theory offers a different perspective. In the grand scheme of a multiverse, our universe is just one of many, each potentially governed by a different set of physical laws and constants. Just as we find a range of climates on Earth, from the freezing poles to the scorching deserts, the multiverse could host a diverse array of universes, each with its unique physical climate. And just as life on Earth has adapted to a variety of environments, it's possible that life could arise in universes with different physical laws than our own. However, our form of life, based on carbon and water, requires a very specific set of conditions, which are met in this universe. So, within the vast cosmic lottery of the multiverse, we've hit the jackpot. We find ourselves in a universe where the physical constants are just right for our form of life to exist. We're not necessarily the center of the cosmic stage nor the result of a divine blueprint. Rather, we might simply be the lucky occupants of a universe that, by chance, has the right conditions for life. In this framework, fine-tuning is no longer a mystery to be solved, but a natural outcome of the multiverse. Each universe has its unique set of physical laws, and we find ourselves in one where life is possible. So, our existence could be the result of cosmic luck, rather than divine design. And what about the Fermi paradox? The question of why we haven't yet found extraterrestrial life. This paradox, named after physicist Enrico Fermi, points to a contradiction between the high probability of extraterrestrial life and the lack of contact or evidence for such civilizations. Given the vast number of stars, and by extension, potentially habitable planets in our galaxy alone, it seems strange that we've yet to detect any signs of life. Enter the multiverse theory. If our universe is just one of countless others, each with its own distinct set of physical laws and conditions, then the Fermi paradox might find its resolution in these cosmic expanses. The theory suggests that while life may not exist in our universe beyond our lonely planet, it could be thriving elsewhere in another universe. The possibilities are as infinite as the multiverse itself. Imagine for a moment a universe where the laws of physics allow for life forms that are unimaginably different from us. Or a universe where life has evolved far beyond our current level of understanding and technology. In these distant universes, civilizations could be communicating in ways we cannot comprehend or detect. But here's the catch: even if such advanced civilizations exist, the cosmic distances between our universes might make contact or communication virtually impossible. The vast gulfs of the multiverse could be insurmountable, leaving each universe isolated in its own cosmic bubble. It's a tantalizing thought, isn't it? The idea that our universe might be just one of many, each brimming with its own unique forms of life. But it's also a humbling one. Despite our advances in technology and our insatiable curiosity, we might never be able to bridge the immense distances between these universes. So, where does this leave us? Well, while we continue our search for extraterrestrial life within our own universe, we can also marvel at the possibility that life might exist beyond our cosmic horizon. The multiverse could be teeming with life, but we may never know. The multiverse theory is fascinating, but what evidence do we have? The answer is, as of now, not much. The theory remains just that, a theory, largely because it's incredibly challenging to gather direct observational evidence of other universes. While it paints a captivating picture of reality, we must remember the multiverse theory is a product of theoretical physics and mathematical models, not empirical observation. Speculations abound on how we might detect evidence of a multiverse. Some physicists propose we could look to the cosmic microwave background radiation, the afterglow of the Big Bang. Tiny fluctuations in this radiation could potentially hint at the existence of other universes. Others suggest that the behavior of particles at extremely high energies might offer clues, but these are for now just ideas, not confirmed methods. While the multiverse theory is compelling, it remains a hypothesis. The search for definitive evidence continues. The quest to understand our universe, or should we say multiverse, is far from over.